You have learned flame test and silver nitrate test to test for the chemical composition of an unknown sample. Actually, in Form 2 integrated science, you have learned different methods to test for the identity of the unknown sample. For example, you use a burning spin to test for the presence of hydrogen, glowing spin to test for the presence of oxygen, lime water to test for the presence of carbon dioxide, and also this one, you have learned how to test for the presence of water. So in Form 2, you have learned this cobalt chloride paper. We use cobalt chloride paper to test for the presence of water. So let's recap of the chemical tests. Let's see what will happen. The following will be the recap of the use of cobalt chloride paper to test for the presence of water. We will add the cobalt chloride paper into 3 different samples: water, ethanol, a kind of alcohol, and also oil, to see what will be the observable change. Here we have some water added on the watch glass, and we'll put the dry cobalt chloride paper to the water. Let's see what will happen. This is a cobalt chloride paper. We've been put in the water. This is a color change. Okay, next. Putting the paper into the alcohol, the ethanol. And next, putting the paper into oil. So how can we describe the observable change when the dry cobalt chloride paper is put into water? You have learned this in Form 2. We describe it like this. Blue cobalt chloride paper turns pink. Or we have another version. The cobalt chloride paper turns from blue to pink. In chemistry, we must describe both initial and final color if we are mentioning the color change. Now how about the dry cobalt chloride paper being put into oil and ethanol? Both of the cases, you can see the obvious color change. Actually, we may describe like this: no observable change. So as a summary for this method, we can say water turns blue cobalt chloride paper pink, or we may say that water turns cobalt chloride paper from blue to pink. Or actually, I should put one more word here: turns dry cobalt chloride paper from blue to pink. Turns dry blue cobalt chloride paper pink. I prefer this version. Turns dry cobalt chloride paper from blue to pink. Other than the use of dry cobalt chloride paper, actually we have another method to test for the presence of water. It's called anhydrous copper-2 sulfate solid. Yes, copper-2 sulfate. It is the chemical we use when we discuss the crystallization. However, this time it is anhydrous 脫咗水嘅. And some of you may be curious about the 2 here. Actually, the full name, the actual name is called copper-2 sulfate. You'll learn this in Form 4 if you study chemistry. In Form 3, if you don't have the 2 here, I will not deduct you any mark. So let's see what is the appearance of copper-2 sulfate solid. This is a bottle of anhydrous copper-2 sulfate solid. So you see, they exist as white solid, white powder. So what will happen if we add the anhydrous copper-2 sulfate solid into these 3 samples? I have recorded a video and show you here. First, we add the anhydrous copper-2 sulfate solid into the water. See. Okay, it turns from white to blue. Now how about if we put the solid into oil and ethanol respectively? Let's see. This one we're going to add anhydrous copper-2 sulfate solid into a sample of ethanol, a kind of alcohol. So see, the white solid is still white in color, no observable change. Let's see what will happen if we put the anhydrous copper-2 sulfate solid into oil. So it is still white in color. So how can we describe the observable change here? If we test the presence of water by anhydrous copper-2 sulfate solid, the white solid turns blue. So in a conclusion, water, what is the action of water to anhydrous copper sulfate? Water turns white anhydrous copper sulfate blue. Now, I repeat, you must have this word anhydrous 脫咗水嘅 copper sulfate. Lastly, how can we test for the presence of water in seawater? If we repeat the experiment with seawater, what will be the observation? The blue cobalt chloride paper turns pink, or it turns white anhydrous copper sulfate solid to blue. So I'm not conducting this stupid experiment here. So our conclusion will be seawater contains water if we have these observable change when we test the presence of water by cobalt chloride paper and anhydrous copper sulfate solid. Now, I leave a question here. What will happen if we test for a mixture of ethanol and water? If we repeat the experiment with a mixture of water and alcohol, so what will be the expected observable change? I'll let you think and then I will play the result here. 好，開估咯喎。為咗證明我哋冇出術嘅 we add some of the alcohol on the watch glass and also we add water on the watch glass and repeat the testing of water, the test for the presence of water in this mixture. 好，準備 cobalt chloride paper turns from blue to pink, and also anhydrous copper sulfate solid. It turns from white to blue. So actually for this test, it can only test for the presence of water. It cannot test whether it is pure water. Here will be some of the limitation of the qualitative analysis. So we can test for the presence of something, but if we really want to test the purity of something, we need to do another type of analysis. I will discuss it in form for chemistry if you study chemistry.